Hello everyone, hello. Guys, welcome again in this video. Guys, you remember last time we talked about learning unit 1, learning unit 1, unit 1, but we talk about Kirchhoff's law, but we talk about Kirchhoff's law, first concept, which was junction rule, but in this second concept we're going to learn about loop rule. So loop rule is simple, very simple, like junction rule, but in the textbook, in the learner guide, they said sum of voltage drop is equal to sum of voltage rise, which is not wrong, which is correct. But sometimes we used to complicate that thing, sometimes used to complicate people, but I'm going to show you in the simple way instead, maybe of you not get stressed about that sum of what sum, which is the same thing that I'm going to do, but explaining in different way. So like rise, you can see guys here, when you talk about loop are just space, this space between the space on both sides between between the node, this is the node, and then this both side, these are the two sides we're going to call loops. So guys, like in this circuit, because we have only one node, we're going to have two loops. So the first loop will gonna be this one, and the second loop will be this one. So guys can see. So now let's say, like for example, in this question, in the loop, in the junction rule, the first concept, we was busy dealing with current, how we interpret current at the node. But in this case now, with loop rule, we're going to interpret voltage drops. We're going to talk about voltage and voltage drop and voltage rise. So in the simple way, like how to interpret, cause we have two loops, this one and this one, we're going to have two equations. Let's say for the first equation, let me take this one for side. For the first equation, focus on the first loop, which is this one. Let's say first equation. What will happen here, guys? First equation. What will happen here, guys? You can see on the first loop, this one, we have how many resistor here, because the loop is this one. We have resistor R1, resistor R2, and resistor R3, and we have a voltage, which is the source voltage E1. You can see that, but across each resistance, we're going to have a voltage, which is called the voltage drop, that we're going to have across each resistor. The thing that you must know, voltage in the simple way, voltage drop, let me call it V drop, because V drop will oppose V rise. V drop will oppose V rise in each loop. So like let's take for example, for our first loop, which is this one, loop 1. What will happen in loop 1? I said voltage drop is the voltage that will drop, the voltage across R1, across each resistor, that we're going to call the voltage drop. So like in this case, let's say, because you can see guys, our current, our voltage, you can see our voltage here, the voltage, you can see the voltage now, it's positive to negative. So in a simple way, if I choose positive side, if I can choose my positive side from the voltage right, which is E1, let me say from positive to negative, I represent one arrow like this. So which means my loop is gonna work like this. positive. My positive will start here and turn like this. This will be my loop. So in a simple way, if I represent E1 up, which means R3 voltage drop must oppose voltage rise. So in this case, voltage across R2 will oppose E1. So because it's still in the same loop, we won't care about this side, we only this side, loop 1. So in loop 1 we still have another resistor which is R2, but on each resistor I was saying like the voltage drop oppose the voltage rise, which are voltage rise the voltage from the source. So R2 also will oppose, the voltage will oppose. Same thing, you can see this resistance is connected to this same voltage, so which means the voltage drop also will oppose. You can see the thing will go like this, connected to this one, and this one oppose this one, so connect with this one, and then they're going to oppose the voltage drop. So now in this case, now we're going to have like voltage drop, which we can call VR1. Here we can call it VR2 because of resistor 2. Here we can call it VR3 because the voltage drop, and then here we call it E1, like the way is it. So now what we're going to say now, if we choose E1 our positive side, so we mean because E1 will oppose the other voltage across each resistor here, so we're going to have E1 in another, we're going to have, if we choose E1 like plus, like positive, we're going to have E1 plus plus we're going to have E1, because E1, if you choose E1 like positive, because the other voltage you oppose is going to be minus R1, VR1 minus VR2 minus VR3, which is equal to 0. If we choose E1 positive, but we can send this all this minus on the other side, like saying VR1 plus VR2 plus VR3 so equal to E1. So guys, you can see, so if we go back in this formula where they said in this in the learner guide where they say sum of voltage drop is equal to sum of voltage rise, which is the same thing like here, voltage sum, this sum of voltage, these are voltage drop equal to sum of voltage rise. So you can see guys, in the simple way how we interpret the loop, the voltage drop and the voltage rise. So like I'm saying, I won't make long video because of WhatsApp group. You're going to see all my videos on YouTube channel, my YouTube channel, which is Durvil. Let me write here, Durvil marigold board. On YouTube, very completely free and free. So now, cause I won't make a long video, in another video I will come back with loop 2. So okay, thank you, and again see you. Hello, let's continue now with loop 2. So now in loop 2 we're going to apply the same thing like we apply in loop 1. Like I was saying, voltage drop oppose voltage rise. Same technique we're going to apply here in loop 2. So let me focus now. So now we can say in loop 2, this side in loop 2, we have two voltage now. We're going to have voltage E1 and voltage E2. Sharp. So you can choose which one exactly that you want to start. You want to start focus on voltage E1, E2, or on voltage E1. So in my case here, I'm going to focus on voltage E1. So which is this one, like positive to negative, same thing. I use my direction positive, this positive to negative. I prefer positive to negative because it makes their job to be very simple. So now here, let me use the red pen. So what will happen now? Positive to negative. See, if I represent my voltage rise like this, positive to negative, positive like this to negative. So I say voltage, the resistor that are connected to that voltage will oppose the voltage drop across each resistor that is connected to the voltage from the source. That voltage source will oppose this voltage. So in this case we have R3 and R2. So R2 will oppose VR3 will oppose E, and this one also will oppose this one. So you can see now we're done with the first voltage, which is E1. So now let's come in voltage, because if you check from the node, only R2, R3 are connected to E1. So we come back now to this other E2. If I choose also that E2 like this up, goes from positive to negative like this, so the voltage drop occurs because these are R4 and R4 and R5 are connected to E2. So if I choose E2 like up like this, so which means this one will oppose and this one also will oppose. Right? Sharp. So what happened now? This is my loop. I can just connect everything like this if I want. I can connect everything for my second loop. But it's not say like you must, because this one it's for you to interpret the circuit. So this one now it's my loop 2. So my loop 2, let's start by E1. We can see E1 is pointing up, so the arrow is pointing 1. So let's choose it like a positive. If my E1 is positive, everything that will oppose E2 will be negative. So E1 will be negative. So E1, and then here we have at R3 we have a voltage drop, which is R3. We have also another voltage drop here, which is R2 VR2. Another one here, which is VR4 and VR5. So we're going to have, because VR4, you can see VR4 is opposing E1, so we're going to go minus R3 minus VR2. And then if we check now, let's focus here. If you check that circuit, if I follow that row like this, because now it's a loop, everything is combined now. It's combined. If I take, like I say, R1, like I say here, E1 up, so this one oppose, but if you check VR4, they're going in the same direction, and E1, VR4 and VR4, this one, and E1, they're going, the arrow is pointing up. You can see up also here. So we're going to have VR4 same sign with VE1, which is going to be VR4 plus VR4, because same direction, because I choose E to be positive. So if I check now also here, VR5 is going the same direction, and VR is going to the same direction, and VR5, so it's going to be also plus VR5. But if I check here, you can see E1, E2 is opposing V. If I go like this, you can see VR5 is opposing E2. So which means E2 will be going to have the same sign with VR3. So it's going to be negative, which is E2 minus E2, which is equal to 0. So from here, we can apply the technique, the rule from the study guide, which they say sum of voltage drop equal to sum or voltage rise. So my voltage drop are voltage across the resistance. So the resistance, so we're going to have let's start by positive. Those are in positive. Let's start by R4 plus VR 5 minus VR3 minus VR2. Now we're going to say voltage rise. We're going to let me send E2 first, because the one that is negative is going to be positive on the other side of the 0 of the equality equal. So it's going to be plus. If I send, no, it's going to be negative this E1. This E1. So we're going to have negative E1. So guys, in the simple way, this is how to interpret, how to generate equation from Kirchhoff's rule using loop rule. So yeah, so now in the next video I will come back with that question that I sent inside the group, where I'm going to explain everything. Now when we're going to start solving this type of question, we're going to apply it at the same time, junction rule and loop rule. But those ones I'm going to explain in this other video that is coming, when I'm going to solve that question about 1.5 from learning unit guy. Thank you and sharp.